from last week. I'll get those up in the next episode. I've been slack. My apologies. Now there's something I was going to say, and it just escaped me. So I'm sure we'll talk at some time. Oops. Oh, we've got the door open. This is the heat. If there is a central theme to this class, it is why do projects fail? And a lot of them do. The numbers you'll see are all over the place, but basically once you get above a certain level of complexity, about 50% of all software projects either fail completely, meaning they're never finished, or they go into production but with greatly lowered return on investment, if you will. Less functionality, less capability than envisioned. And part of the problem, well, it's root causes here. It's hard to estimate how long software is going to take. We're back to Armor. You're going to hear about Armor almost every class. It is that pesky little bit of invention. To the extent that you're doing something new, that you haven't done before, that your team hasn't done before, or in some cases that nobody has ever done before, it's very hard to predict how long it's going to take you to do it. You're going to run into problems you don't anticipate. Brooks points out that often we don't know what we need to do, but he also points out the fact that we tend to not want to give bad news. How many of you have had an experience of trying to give bad news about a software project to management above you and had it sort of rejected or scoffed or whatever? Any of you? Not a lot. Anyone want to share a horror story?
I'm just thinking of grading, like when we turn in homework.
Uh-huh.
That's not done yet. That's bad news.
Okay. What else? Software project, yeah.
I was in charge of researching something new because they didn't know. They wanted to change graph into REST, like automatically, endpoints, and I was in charge of looking at software to do that. And there was one that everyone thought would work. I tried it and it didn't work for a use case, and nobody wanted to listen to me, so they did it again, wasted a bunch more time, and then came to the same conclusion.
That's actually a very interesting pattern, yes. You say, no, you can't do it with this, and they say, well, I'm going to manage. I'm telling you, you have to do it this way. And this is part of me being a manager. In fact, I just read a Dilbert strip to that extent. Dilbert estimates a project for 3 days, and pointy-haired boss says, I expect it in 2 days. Dilbert says, I can't do it. I'm supposed to take 3 days. Says, I'm showing leadership. And of course, Dilbert comes back after 2 days and says, it isn't done. We tend to confuse effort with progress. Now, the Mythical Man-Month, what's he talking about? He's talking about, people try to avoid the term Man-Month or Staff Month simply because of Brooks' book from 40 years ago, almost 45 years ago. The idea is that, okay, we think this project is going to take 20 man-months, and so if we have 2 people on it, it's going to take 10 months. If we put 4 people on it, it's going to take 5 months. Software does not work that way. It is not fungible. It is not compressible. There is an inherent incompressibility to software for a number of reasons, part of which is the actual work that needs to be done, but part of which is Armor, the actual invention that needs to be done, the problem solving, the figuring your route through the dense forest to try and get to the mountaintop. We often lack the courage to say we don't know when it will be done. Again, I've already mentioned in here, Pages, I spent a year saying, I'm not sure when it will be done. Or saying, this is when I think will be done, and then go back a month later and say, no, that's not true either. This was very transformative for me professionally. But it was also very painful and awkward. Schedule progress is poorly monitored and hard to measure, and we're going to talk about that when we get into metrics. And when the schedule slips, the impulse is to add staff. How many of you have been on a project that's late and they try to add staff to get the project on time? See, most people know, at least pays lip service to Brooks' Law, which is that adding people to a late project makes it later. But it still happens. My daughter Crystal, at her job, they had an in-house project that was late, and the CTO came in and said, okay, we're hiring 10 consultants to come in and work on this as well with all of you, but this totally isn't Brooks' Law. We're not making the project later, which of course they ended up doing anyway. It was something of a disastrous project, but that's a whole other discussion. Yes?
Are there certain types of projects where adding people can be effective?
Yes, and that's discussed in Accelerate. Accelerate, where it talks about architecture, talks about designing your system with loosely coupled chunks. Rather than having one big mass where everything has to talk to each other, do it as a series of nearly independent chunks that have stable, well-defined interfaces. And in those cases, you can add people, you can drop a new chunk in, and if you've got the interface defined, you don't have the communication, you've already established communication, simple API. And so the people in this new chunk can be added to get that work done while everyone else keeps working on the rest of what they've got. So yes, and Brooks will actually talk about this when you get to chapter 17 or 18 in Mythical Man-Month. He goes back to his original book and says, here's what works and here's what doesn't. And he talks about situations where Brooks' Law really doesn't hold up, where you actually can, or in some cases need to add staff. But he says it remains a very effective first order or zero order approximation. My observation is that, yes.
How does like pair programming fit in with Brooks' Law?
Pair programming isn't adding people to a late project. You're programming from the start as two people communicating with each other.
So is adding a person later on into a pair programming situation?
Well, if you add a person later on, if you're solitary programming and suddenly the company says we want everyone to do pair programming and we're hiring an additional program for each person, stop and think about the time it's going to take that person to come up to speed and to understand all the things that you do. If you've been pair programming from the start, or if you're selecting from within the existing software team, then you don't have that ramp up.
Okay.
Any other observations, questions? All programmers are optimists. Adele Goldberg, one of the co-inventors of Smalltalk, one of the pioneers in object-oriented development, says only optimists build complex systems. It's the simple matter of programming mindset. Oh, we'll do this. Now, all of you have just written your requirements. And most of you broke it down into here's for the first demo, here's for the second demo, and so on. I will guarantee that most of you were overly optimistic. That's what you're going to accomplish in your first and second demos. Because you looked at it and you sort of, in your collective head, see it and say, yeah, this is how it's going to work, and we just have to do this, and we just have to do this. Mark my word, as you go through this semester and actually work as a team on your project, you know what you're going to be doing? You're going to throw away features. Because that is the only way you can meet a schedule. Can't do it by adding people. Won't do it with silver bullets, with magic tools. The only way you can preserve a schedule is to throw away features. Defer is the term that they use. We're deferring this feature until release 1.1. We're deferring fixing this bug until release 1.1. The big mistake I made at Pages when I put together the schedule was that prior to Pages, almost every software project I had worked on professionally, I was the sole or principal programmer. And I had a lot of experience, and I was actually very good at estimating my work and how long it was going to take me to do X and so on. And when I was putting together the first draft schedule for Pages, this is before we hired a VP of engineering, I thought, well, I basically looked at every task and assumed if I were doing this by myself and I didn't have to communicate with other people and I had no dependencies elsewhere, how long would this take me? This is one of the reasons why the project was a year late. Even with the corrections to my schedule that our VP of engineering made. We assume it'll only take as long as it ought to. Now, the next point. If you stop and break down your project into a series of tasks, you can say, okay, this task, I'm pretty certain is only going to take a week. And this task is only going to take a week, and this task is only going to take a week. And let's say I have a 90% assurance of that. How many of you had statistics? What happens if you start multiplying probabilities that are less than 1? It drops off very rapidly, doesn't it? You know, it doesn't take a lot of 0.9 times 0.9 times 0.9 to get you down below 0.5. That's exactly what happens with projects. And with projects, you may actually have dozens or hundreds of tasks like that. And your schedule assumes that they will all go perfectly. And so if things start to fail or slip, it has this cascading effect. One of the things when we do PERT and Gantt charts, when you do PERT and Gantt charts, I don't have to do them. In your PERT chart, you'll have a critical path. And the critical path, we'll talk about this later in the class, critical path is where if anything on this path slips, the whole project slips. Thus, we have this maxim. It is very, very easy to lose a day on your project schedule. It is almost impossible to make it up. I'll often say, if you learn nothing else from this class, learn this. If you learn nothing else from this class, learn that. It's very easy to lose a day on your project schedule, and it's almost impossible to make it up. And about the only way you make it up, throw out features. Remove work that has to be done. An initial problem, we'll talk about this. We've already mentioned it some in class. We pick all the low-hanging fruit first. You know, doing a project, hey, I've got these great interface tools and this IDE, and I can mock up the menus and the windows, and I've got this, and I've got an engine, and do this. And you get well into the project, and you're feeling very good about what you're doing. And then all the easy stuff goes away, and you're left with all the nitty-gritty difficult stuff. You know, it's the 50-ton boulder right where the foundation is supposed to be. And so we often have a sense of great progress early on in the project. And then our rate of progress starts to slow because we deferred all the hard problems to the last. And often we'll get ourselves. What are some other ways in which we tend to be overly optimistic? How many of you have ever been overly optimistic in estimating how long it would take you to program something? Yeah. And the rest of you are lying. No, seriously, what any experiences where you thought something was going to take much less time than it actually took?
Well, we typically assume we're going to write it right the first time.
Oh, yeah.
Debug.
And that's going to be a big issue we're going to talk about with Brooks here. Yes?
So I had a little bit of a different issue this last week. I understood the algorithm I was supposed to be implementing, but because I was learning Python still, figuring out how to actually do what I wanted to do in Python. I knew exactly what I needed to do, but actually doing it in Python ended up taking a lot more time than I thought it would.
And this is why one of the things I said at the start of the class for your projects, that every semester I have teams who say, hey, we want to use this because we all want to learn Unity, and none of us have any experience with Unity. And basically spend 12 weeks learning Unity and not doing much else. Because you're dealing with a tremendously complex system, you're dealing with unknowns that are in the very tools that you're using. And then you start, hitting Google and Stack Overflow and everything else. And, hey, I do it. I do it all the time. I was just having this discussion with my son, who's he manages a lab for the IT department over in the Crabtree building. But he's doing some programming on his own, and he's learning Python, and he's trying to control a little color LED with a Raspberry Pi. And he found some code that talked about how to set up event handling for button pushes and so on. But the code, the tutorial he found didn't explain to him that actually what he needed was to be in an event loop. He had code that just ran all the way through to the end and stopped. And he had figured out on his own. He said, is this what I'm supposed to do? I said, yeah. Basically, you go in, you set up an event loop, and you just do a do while, true, and then respond to the events. There are a dozen little things like that. There are hundreds of little things like that that you often have to learn on the project. There are a few things. The reason why Stack Overflow is so popular is there are a few things more valuable to us than working code. Get a sample of working code. What do? Bring it up, you run it, then you change one thing at a time. Programming, there's actually one of the O'Reilly book covers. Any of you seen the O'Reilly book covers? They're great. I'll put out a link to that. These are parodies on the O'Reilly that's basically real programming. It's programming by looking things up on Stack Overflow. It's the name of one of the books. There's one that says programming by making small changes to your code. Okay, the Man-Month, we actually just talked about that. How many of you have been on a project when someone new has come in and you've seen a portion of the project sort of grind to the halt as this person starts to come up to speed? To learn the tools, to learn the code, to learn the underlying assumptions that all of you who are already there take for granted. Anyone want to share stories? Yes?
Actually, it was one of my buddies. I was able to get him a job at where I work, but I didn't expect them to put him on my team.
We'll keep this all quiet.
So he's very talented, but he's very self-taught. So I had to teach him the section that we were going to put him on the project that we were working on. And had it been one of our more experienced developers, knowing the ins and outs of the project and everything, it would have been done in a couple weeks. It took him a couple months. But he was able to learn, but it didn't get our project late.
Yeah, and what was the impact on you while you're doing that?
A lot of patience.
Well, and a lot of time taken away from you.
Oh yeah.
This is what underscores Brooks' Law. You bring someone new into a project, and you don't often realize how much of the project is shared experience and understanding of what works and what doesn't work. Now, what also, as per the last thing, how many of you have been on a project where someone who was a key programmer left and have seen the impact of that on the project? Yes?
Actually, I took over for this programmer. He was in the middle of doing something for one of the colleges here. And the project ground to a halt until I learned the systems, and then we were able to finish it out. But it took so much longer than he'd stayed and whatnot. It probably took a couple extra months.
Were there other hands up? This is important. Oh, yes.
I was working on a research project, and the student who was spearheading the development kind of left after summer work with Amazon, and there was just no like overarching scope on the research anymore. Like we had the experiment tests and things we were going to run, but we didn't really know what we were going to do with it after that.
There's a real issue with knowledge transfer and knowledge retention when you have turnover within a project. And the thing to consider is it's usually your best people that lead because they're the ones having the most money thrown at them or whatever. Going off to Amazon or whatever. In the industry, we talk about the truck factor, which is how many of your developers can be hit by a truck before the project fails. And it's a very real issue that a case I just testified in Denver last month. One of the issues there was that the source code that was being claimed as a trade secret, there was one person who developed the whole thing. It's about 1 million lines of source code. Said person was in his late 60s, kind of like me. And there was a real issue there. The other side was trying to claim this code is valuable, in spite of the fact that, for starters, it was classic ASP. So the language itself had not been updated in almost 20 years. The developer, it was one developer. You had all this knowledge locked up in his head. And any issue, all it takes, hey, I'm 66. I'm well aware of my mortality. My brother-in-law, who's only a couple years older than me, is right now in ICU looking at getting heart surgery and with very high blood pressure. Stuff like that can happen. People can get hit, they can leave, things can change. And the question is, how does your organization keep functioning at that point? Okay, this gets back to something someone else was mentioning. Brooks says, in your schedule, you should plan on spending half your time doing testing. I can tell you, no one out in the industry thinks that they're going to spend 50% of their time testing. But Brooks' comment is, no one thinks they're going to, but they do anyway. And as someone who's reviewed a lot of failed projects, my response is yes. This is exactly why a lot of projects are late. They get to a point, they think they're just a few weeks away, and they spend a year trying to make the thing run right. Yes?
Can this be mitigated all by people testing as they're building their software, right? Because I know you do integration testing, but sometimes you can incrementally test a script or a class that you're building, right? So you've already done the testing as you build it.
Short answer is yes. In fact, this is one of the reasons why you have Accelerate on your reading list. Continuous development, continuous integration, automated testing can mitigate this because you literally are always testing and always pushing stuff into production. However, and this was a useful counterpoint, one of my students last semester said, oh yeah, we do DevOps, CI, CD, integrated testing at where I work. Says, but the test suite is awful. It doesn't give us the coverage we need. It lets a lot of bugs through. So we're continually pushing buggy software into production. So the short answer is yes, and this is one of the reasons why Accelerate is on your reading list. There are technologies and techniques to mitigate this issue. And having fully automated test suites with sufficient coverage is an important part of that. And your whole approach basically turns inside out. We'll talk about that in a later lecture at SQA, where everything is supporting the development effort and everything is getting tested and reviewed as it is done. Now, The 90-90 rule, and this doesn't originate with me. I've been hearing this for decades. 90% of the work you have to do takes the first 90% of the schedule. The remaining 10% of the work takes the other 90% of the schedule. This is such a common syndrome where you'll see a project get to where people first, and we'll talk about the idea of, oh, that's about 80% complete. It's like, based on what? 80% of what? But people say, oh, it's 80 to 90% complete. We're almost there, and then the project will drag on for months. This is because they're doing the testing that they've put off. It's because they've deferred all the hard problems to last. And it's because they have no good metrics for actually seeing how close they are to being finished. And the underestimation of the system testing you need. At Pages, our CEO, Larry Spellhawk, bless his heart, had great admiration for him. But when he came on board, we closed on venture funding after a year and a half of beating the bushes and trying to raise funding. Closed on venture funding, hired Larry as our permanent CEO. And I was talking to Larry. I said, I want to hire a director of quality and have an actual QA department. And Larry said, what do we need that for? He says, can't we just hire some college students for like 3 weeks before we ship and have them pound a lot on the keyboard? And I said, no, Larry, we can't. But that's the approach to quality assurance that a lot of organizations take. To Larry's credit, he listened to me. We hired Dave Creek, who is an outstanding director of quality. He put together an actual QA staff, and during the long grind towards actually shipping, I think Larry came to appreciate how essential it was that we have a professional QA staff and actually be able to trace and track bug opening and closings. Comments, questions, horror stories? Anyone? Okay, it's a long lecture, let's move on. Okay. Gutless estimation. Everyone's guilty of this in our industry. Usually until you've been through your first, at Pages, I was pushing back. I had a schedule. Larry said this is 6 months too long. I pushed back, but eventually agreed and came up with a new schedule that was 6 months shorter, which we didn't meet. Actually, we're a full year late in shipping. That turned me into a curmudgeon as far as schedule goes. But what you'll find is that in our industry, it's very common to pick estimation dates that have no basis in reality. It's sort of, oh, we have to have this shipped by first quarter of next year. And it's like, well, what exactly do you want to ship? Because there's not a lot we can actually get done before then. You have negative political and managerial pressure towards getting realistic estimates. We want to do this. It's going to take 3 years. We don't have 3 years. Well, it's what it's going to take. Management does not want to have that, and so what we get is when a product's late, we add people to it, work longer hours. Both are counterproductive. And, as you will hear me say again and again, the only real solution is to drop features. Drop features and defer bugs. We've all experienced getting software and getting angry with the software we have because we encounter bugs in it. But I can tell you that that was a trade-off someone made. Someone said, okay, here are the set of bugs that we are willing to live with and ship the product with. And that is a trade-off, yes.
Who in an organization makes that decision?
Huh?
Who in an organization makes that decision?
Who?
Yeah, who gets to say, this bug is okay, this bug is not okay?
Ultimately, it tends to be an argument between engineering and management, particularly engineering and marketing. But with Pages, our version 1.0, we had, I believe, around 400 bugs that were actually open, but all deferred, because we considered them either innocuous enough or not worth delaying shipping, since we were a year late. Any further? Most commercial products ship with hundreds, if not thousands of bugs in them. There are bugs in Microsoft Word that I still swear at, and I've been using Microsoft Word for 30 years. It's like, why don't they ever fix this? Yes?
Are some of those bugs used by people to the point where it would break too many things to fix those bugs?
Well, see, this is a key issue. The issue is backwards compatibility. This is, and we'll talk about this in a later lecture, but this is a very real issue. Is Microsoft has at several times tried to get rid of the MS-DOS underpinnings in Windows, the command shell and so on and so forth, and move off just, and people scream bloody murder because there's a vast amount of software that may depend upon the existing. Sometimes it's the bug, sometimes it's simply just the more primitive versions. And it takes a great deal of nerve to say we are moving forward, we are dropping this, we know people are going to scream at us, but this is the future, and we're not going to keep supporting this bug or this feature going forward. Any observations with gutless estimation in projects you've worked on? Where you've seen people make estimates and you're sitting there shaking your head and saying, no, there's no way we're ever going to do that. Yeah.
Well, I know specifically in my job that I keep getting asked from people, asked like, how long do you think this is going to take you? And I'm like, well, if things go well, it's going to take me like an hour, or if things don't go well, it'll take me like 2 or 3 days. I don't know what to say.
And no, actually, that's good, because you're back to armor with that. You really are. But this is one of the reasons why, and trust me, this goes back 50 years. I can show you cartoons from 50 years ago that show this gulf between management and IT. Management does not like IT because we cannot make predictions that come true. And what really frustrates them, if we were always late, then they could factor that in. But how many of you have had this experience? You're working on a project, someone comes to you and says, can you add feature X? And you say, oh yeah, piece of cake. Sit down, hour later, bam, it's in there, it works. It's like, oh cool, can you add feature Y? No. Or it'll take a month. Or we'll need to hire a specialist in this. They're like, well, I don't understand. This took you an hour, now you're saying a month. What's the difference? But that stuff we see clearly, and it drives management nuts. And they don't trust IT because of that. Yes?
One of my favorite XKCD comics is specifically about that, where he says, I need to know, I want an app that tells me where a picture was taken here. And the guy says, well, okay, that's a simple geo lookup. That'll take me like 2 weeks. And I want to know if the picture is a bird. I'll need 5 years in a research team.
Yeah. And the person is like, what? I don't understand. But that's exactly right. We are like the recalcitrant wizards. And sometimes we work magic, and sometimes they're figuring out if we're just trying to shine them on or something. It's like, no, really, I'm not trying to shine you on. It's hard. Why is this easy and not it's hard? Well, you'd have to have a CS degree before I could explain it to you. Okay. Is chapter 7, why the Tower of Babel failed? He says, he's drawing on a story out of Genesis. They had a clear mission. They had manpower, materials, time, and technology. But going with the story, what they lacked was communication. And when the communication broke down, the organization broke down. I actually co-authored a short story based on this, which I may post so you guys can read it and you get a kick out of it. Or not.
Do it.
But the point is, it's basically a steampunk retelling
Nice.
of the brother of Jared and Jared. But the point is that communication makes the issue. We're back to Conway's Law. We're back to getting the right information upstairs. When you read later on, you're going to read, one of the readings is a thing I wrote called The Thermal Climate Truth. As information about a project moves up the management chain, bad news gets dropped. And it becomes rosier and rosier as it gets towards the top. And this leads to an issue that Brooks talks about. Oh, one thing out of this slide is there's a reason I said that the project manager and the chief architect have to be different people. Their priorities inherently conflict. Classic story, apologize for already told to you. Group of tourists over in Europe taking to visit the shop of this great wood carver who does these gorgeous carved doors for churches. And he's at work doing these meticulous carving on this big wooden door. And everyone's sort of gathered behind him, watching in silence. And finally, one woman gets up nerve and says, "Excuse me, how long does it take you to finish one of these doors?" And the wood carver turns around with a stricken look on his face and says, "I never finish them. They come and take them away from me." That's software. You never finish it. They come and take it away from you. Having served for that first year and a half at Pages as both the project manager and the chief software architect, you never want to do that. You end up fooling yourself, if you will. It becomes very hard to basically make the hard calls and to be as thoroughly realistic as you want to in your assessments. Yes?
I recognize when I'm working on a project, I tend to ignore bugs that I don't want to deal with. And so when I'm done with a project, I have forgotten about that bug. And so
Oh yeah. Yeah, that's all you need. You want that separated there. Okay, chapter 14, hashing a catastrophe, talking about project failure. How does a project get to be a year late, one day at a time? Another truism, keep this in mind. You usually don't have big, well actually you do, but they happen at specific times. It's not like each week you say we've lost 2 weeks. You're pushing ahead and you're mentally thinking, well, I can work weekends and make this up and we'll bring someone in to help with this and so on and so forth. And in the meantime, the whole project is getting later and later. We have, once again, the 90% rule. Now, I think I've mentioned to you that time and again in my professional career, when I think I've come up with some new original observation, I'll go back and read Mythical Man-Month and find it's been sitting there in plain sight all along. One thing I thought was original to me in all my review of failed or failing projects over the past 25 years was how often the project slip occurred 3 weeks before the deadline. I started teaching this class, happened to go back and go through it. Sure enough, Brooks has got it there. Underestimates of project schedule do not change significantly during the activity until about 3 weeks before the scheduled completion. You wrote that back in 1975. It's eerie how accurate that is. Because what happens is that here's your timeline, here's your deadline. Deadline and timeline. Assume this is moving towards upper management. Talked about the thermocline of truth. The bad news is very slow to get upstairs until you can't hide it any longer. And that tends to happen just a few weeks before it goes live, and it's usually at this 3-week spot that it hits. Now, here's a question. Without me telling you, can you guess how much a schedule usually slips by at this point when they slip the schedule? No? 6 months. It's almost always 6 months. I have reviewed multiple projects where you have the same pattern. Green was not in here. There we go. This is 6 months. And you have the same pattern, and right at 3 weeks, it punts, and right at 3 weeks, it punts. I've seen this happen 3 or 4 times on a single project that I've reviewed. Oh, you know what else also happens quite often? Right here, after the second slip, the developer suddenly decides we're going to do Agile. No prior experience. Maybe one person on the whole team has ever done anything with Agile before. For some reason, I mean, I've seen it in multiple projects. It's after the second slip, they suddenly say, we're going to do Agile, and this usually lasts for about a month, and then they drop it. Because they realize they don't really know what they're doing. Any observations? Any of you been on field? Yes.
Just the fact that that corresponds exactly to what I see in like I follow video game industry news.
Oh, oh yes.
Like, it's almost always the 6-month delay.
Yep.
And then maybe another 6-month delay almost every time, and it's usually 3 weeks before their announced due date that they delay it to 6 months.
I enjoy reading Kotaku because I follow failed game projects there. And speaking of failed game projects, Star Citizen?
Yeah.
Oh man. I've been for several years I've been going, this is a train wreck, this is a train wreck. you don't raise, what are they up to, $100+ million? Nothing, I mean, it's just like, oh God, this is such a classic failed project. Yeah, I know, well I mean, that's the sort of game I like, and it's kind of like, oh, this is a disaster. Anyway. Okay. Not willing to pass bad news uphill. You'll read thermoclimatic later. We're going to go over metrics. I won't feel it there. Peopleware, chapter 5. The point they make out of Peopleware is that managers will pile work on you because they'll say, well, work expands to fill the time allotted. So if we don't require a lot of work on you, you're just going to waste your time doing stuff. Parkinson's Law was actually a satirical piece. It wasn't real research. And most of us have things we'd rather be doing. How many of you have worked overtime on a software project? How many of you have ever put in 60 hours a week on a software project? 70? 80? 90? 100? I've done that. I put in 100 hours a week on a software project. Basically working 40-hour shifts. And my point is, that's how you burn out. And when you get into Peopleware, what you'll find out is that there's only so many hours of productive programming work you can get out of people a week. How many of you have been working on a software project, putting lots of time in, and finally hit the wall? You feel like your brain is melting. And you just have to go do something else. Management, yeah. Oh, question, yes.
Well, I just had a comment because I've had times where I work on something for 8 hours straight, get exhausted, just go play a video game, go to sleep, wake up the next day, I solve the problem that I was working at for 3 hours in 10 minutes.
Yep, oh yeah,
And then
oh
I get,
yes.
and then I get very frustrated.
It's kind of like I should have quit school. The problem is that management thinks, again, it's like building the pyramids. Lots of bodies, lots of effort, continual effort, moving these big bricks uphill, and damn, it'll happen. Software engineering is creative and frequently unpredictable work, as per your comment. Sometimes you have to just walk away, and then you come back the next morning and think, oh, God, this is so obvious. Or my favorite debugging technique, single most effective debugging technique, is I call another engineer into my office and say, I've got this bug. And I start explaining to it, and I get halfway through and say, never mind, go away. Seriously. And that is my single most effective bugging technique. I'll get halfway through, and I'll see the problem, even though I've been beating my head on it for hours. It takes me like 10 minutes of talking, yeah.
What would be your argument versus like using a rubber duck versus another engineer?
Because you don't want to look stupid in front of the other engineer. And that often is what will do it. You'll try to explain things. The rubber duck, that's a nice substitute, but rubber duck is like you're really talking to yourself. It's when you try to explain it to someone else as to what you're doing. Tom Affinito at Taligent, and this predates pair programming by a couple decades, said their single most effective productivity practice was at the end of the day, every engineer had to grab another engineer and spend 20 minutes telling her or him what he'd done that day. Going through the code, basically mini code review. I did this, I did this, I did this. The other engineer says, well, why did you do that? Well, because, no, why did you do that? Oh, wait, maybe I shouldn't have done that. This is basically the same thing that's behind pair programming. But you don't have to sit, next to each other for 8 hours. You can do it in 10 or 15 minutes. Organizational busy work tends to expect. How many of you have been in a situation where you have management expecting you to put in 10, 12 hours a day? You find a lot of that goes to email, phone calls, social media. Anyone been there? Everyone's like, yeah, sort of. It's what happens. You burn out and you start doing other things just to spend your time there. Okay, metrics. Okay, gosh, this is a big issue in software engineering. In fact, this was also an issue. The trade secret thing. It is hard to assess how close your program is to being completed. And there have been vast numbers of papers, or large, thick books. I own half a dozen books on software estimation. The problem is that most software estimation techniques to be successful require that you already know what you're going to do. So we're back to armor. If someone says, how long will it take you to write a design-oriented desktop publishing system in Objective-C, I can say, oh, about 3.5 years. That's what it took us last time. I already know what it's doing. If someone came and said, we want you to do a iPad-based desktop publishing system with design stuff, I would say I have no clue because I don't know what the unknowns are yet. I have no experience doing mobile programming. It's an entirely different user interface, so on and so forth. So, the problem is management wants metrics, so they will ask for metrics that aren't useful or even counterproductive. How many of you have been in an organization that's trying to use lines of code to measure progress in software? Hey, we generated 1,000 lines of code this week. We're doing great guns. It's actually one of the worst metrics ever for a number of reasons. Particularly with the advent of things like object-oriented development and refactoring. Because in theory, you should be trying to reduce your lines of code after a certain point. You should be doing re-architecting and refactoring. Getting commonality, getting things that are more compact. For a metric to be useful, it has to be informative or predictive. It has to tell you something that's worthwhile, and hopefully help you predict or estimate when you're going to finish. It has to be objective. This is the problem with the, oh yeah, we're about 80% done. It's like, based on what? Well, my gut feeling. Yes, and how many times have you written this exact program and said 80% at the point where you were 80%? And it has to be automated, because if people have to do the calculation, they'll stop doing it. It's tedious. Almost all major metrics used in IT projects lack 1, 2, or 3 of these factors. That's why metrics are so bad. Okay, Weinberg. Okay, this is the classic issue. That which gets measured gets fudged. If your progress is being measured on lines of code, what are you going to do? Write a lot of code. Yeah, a lot of generate a lot of code. The classic case is, of course, the bounty on closing bugs, where what you have as a programmer is you know, so we'll offer bounties for each bug that's closed. And so you have the programmers introducing bugs, QA fixing them, and then splitting the bounty. That which gets measured does get fudged. Law of 90s we've already talked about. The law of least resistance. The more human effort required to calculate the metric, the less often and less accurately it will be calculated until it is abandoned. Classic joke. Drunk under a lamppost, looking for someone. Someone comes up and says, "What are you doing?" He says, "Well, I'm looking for my keys." I said, "Where do you drop them?" He said, "Over there." "Why are you looking here?" "Well, the light's better." That's what a lot of metrics are like. The metrics don't actually measure anything meaningful, but they're used because they're easier to be done. They're easier to be collected. If you're ever in a situation where you're dealing with metrics in an organization, this is an important book to get. Slim book, almost philosophical / scientific in its approach, and it basically shows why management by metrics almost always fails. And it pretty much goes back to Weinberg's law. It distorts the environment. If you reward people based on metrics, what they will do is they will find ways to gain metrics. And you will not achieve what you want to achieve, which is actually, in this case, finishing the project. Okay. One of the problems, this is actually, I just took these pictures this morning. And this gets back to something I mentioned a class or two ago. Why is software so hard? Well, real life. Okay? If you look at this, you're going to say, oh yeah, that house isn't done, is it? It's a hole in the ground. Plus, you can probably look at this and say, this isn't going to be a 20-story skyscraper. It's a small base. You know, it actually looked even better before they put the things in, because all you had was a little bit of concrete and rebar at the bottom. Then you look at this and say, this house is clearly much farther along than this house, but look, you have big gaping holes, the outside isn't done, you've got scaffolding, so you know it's not there. Look at this and say, oh, this looks mostly done. It is actually occupied. It's one of my neighbors. But you can see there's still some stuff to be done, the yard still has to be put in, there's paint that needs to be here. And here is a more finished, still don't have a yard here because they're not, this is my house, by the way. Brand new house. They're not putting the yard in until they get all the houses built. This is actually literally right next door. This is, you can see, that's part of the pit right there. And these two houses are on the street right behind here. But the point is that with construction, you can look at this, and at least you have an inherent sense of how far along it is. Okay? How do you do that with software? How do you look at 1,000 source code files and say, oh yes, it's one of these 4? Yeah?
I think part of the problem too is like, you can completely design a house before you build it. Whereas like designing software, if you're designing like a house that has like rooms that can just be generated itself.
Oh yeah.
It's completely a dynamic system. So you can't see what's done.
Well, and what you don't have is you don't have people coming along at this or this stage and saying, actually, I want a 10-story skyscraper. You have that with software all the time. Yeah.
I was going to say, otherwise you have the picture of your house, but oh, just kidding, we didn't put the electricity in. And then it looks like that on the outside, but they have to rip out all the walls and put all the wires in. So.
Oh, yes. Yeah.
You might be able to accomplish it a little bit if it's feature-based. Like, say, if it's features and it's kind of a known timeline for those features, then you might be able to estimate roughly how long it will take. But
if you've got the feature specified, and if you know how long it's going to take you for the features, yes, you can. We're back to how much is invention and how much is now implementation. This is why you don't defer the hard problems. You want to do all the hard invention up front. And then you can say, okay, yeah, this is going to take us this amount of time because we built this and we know what the bounds of the problem are, and we can get the rest of this done. We hope. Now, this is what you use metrics for. This is where you started the project. This is where you're at, and you're trying to figure out where you're going to end. Why is it so hard? Okay, look at the list here. How much analysis do you still have to do? You may still have a lot of analysis to get done. How much invention do you still have to do? Well, we need to figure out how to actually do this, and do this in an acceptable time frame. I've already mentioned, I'll give you a second. I already mentioned pages. One of the driving factors there, if you sit down on a word processor and you hit a key and it takes more than about 1/10 of a second to show up, people will leave it. We put a lot of time and effort into that one little feedback loop so that when a key was hit, we got a character up on the screen within 1/10 of a second. And the longer that gap is, the more unhappy people will be. Someone had a hand gap.
I feel like a big problem with this is that you can be at a point of the project and then you find a library. That library just like rockets you up near the end. But you don't know what libraries exist until you're like sitting and working on it for a long time. And so it may be that this entire part of the project has to be done by hand, or it can be done automatically, and you don't know. So it's
And that actually is a real problem, because you have to figure out what you need done and whether or not, sometimes, actually, my experience is more often it's the obverse. It's kind of like, oh yeah, we're going to use this library. And you use it, you start to rely upon it, and you find the library does not, in fact, do what you need. It's like, oh crap, we have to write this by hand. The library isn't good enough. The amount of discovery, the adequacy of your current architecture, design, implementation. Again, if I get to this point, actually I get to any of these 4 points, and the manager comes back and says, oh yeah, we need to be able to fit 200 people in here. Can you make it scalable? Well, can I tear it down and start over again? Sometimes that's what you have to do.
How comfortable do those 200 people have to be?
Yes. Sometimes it's hard to know the amount of coding that you still have to do. based on where you're at. The amount of testing you have to do. Unexpected turnover. Key person leaves. It's like, oh no, we're in trouble. The market changes. What happens if the developer, in this case of these houses, all right, where did I go? There you go. Gets here and suddenly the city of Provo issues some new building requirements. You can't have copper pipe, all pipes have to be PCB, for instance. Well, if you're at this stage, that's not a big deal. At this stage, it's kind of painful, but you can deal with it. At these two stages, it's going to be expensive. Changes in external systems upon which you depend. An earthquake.
You need the earth to be solid.
Yes, need the earth to be solid. What happens if the city of Provo sewer system in here collapses? I actually had that. I served for 3 years on a high council for married student stake here in Provo. Our stake building, which we had 10 wards in, was up on 7th North and about a half block east of 9th East. So if you know where Vassa is, go up to 7th and you look off to the right, you'll see the building. Middle of winter, our sewer system suddenly started backing up in the basement. And it turned out that the building had its own sewer pipe that went under 7th North and then connected to the city of Provo sewer pipe right under 9th East at 7th North. And that had collapsed. And it took us about 6 weeks to finally get everything cleared and get the city of Provo to dig in there and do stuff up. We had porta potties in the middle of winter out in the parking lot. No one could use the toilets in the building. It was not a pleasant experience. External dependencies. There may be dependencies that your project has that you're relying on, certain release of an operating system, or a feature in the operating system that you're relying upon and suddenly goes away or changes dramatically in the new version. The talent, experience, and productivity of your IT engineers and managers, as well as turnover. We're going to talk about turnover some, but can your people actually do this work? Business process re-engineering. How many of you have ever encountered this issue? This is I've already made a reference to this. This is a situation where you have the end users within the organization saying, we want it to work just like the old system, but better. How many of you have ever been in an organization that suddenly switches over to new software and have seen the resistance that happens?
Yeah, so at the place I worked over the summer, we had this system and they had paid Samsung to use their Arctic cloud service so that they wouldn't have to build their own cloud service. About 3 months after release, Samsung said, oh, we're discontinuing that.
I'm sorry, you shouldn't laugh, but yes.
Yeah, it was pretty bad. People were depressed. Anyways, they decided to roll their own cloud service, and it didn't work super well, but it kind of worked, and so they were able to barely release in time with that. And if you look at the App Store reviews in the Google Play Store, there's all sorts of reviews saying, why would they ever switch from Samsung Arctic? It worked so well before. Why would they make such a stupid decision?
Well, that's the external dependencies and that. The classic case. WordPerfect. How many of you have ever actually used WordPerfect? Okay. WordPerfect was the dominant word processor in law offices. And as WordPerfect started to sort of go away and lose market share, you had thousands of attorneys who refused to switch over to Microsoft Word. When I started doing expert witness work 20 years ago, it was very common for me to go into law offices and find that the attorney did all of his word processing and Word Perfect, and then the poor secretary had to convert it to and from Microsoft Word to deal with the rest of the world. I actually sort of watched over 20 years that vanish. I'm sure there are still lawyers out there who use Word Perfect. But people don't like change. Yes, you had it.
On the same vein, for the longest time, our entire company was built on Internet Explorer.
Oh, okay.
And we managed to switch it from that to the new system. It took like 2 years to migrate, and then as soon as that happened, we figured out they're like, hey, they're going to stop using Internet Explorer after some time. And we're like, yeah, probably a good thing we got swapped over.
This is also the reason why you have a lot of failed ERP project, enterprise resource planning software. This is stuff like SAP, Bond, and so on. Because it requires changing how you do business to adapt to the software. And you have tremendous resistance within the corporation to doing that. It's hard to predict the overall complexity of the system, and simple problems such as scope creep, conflicting requirements, so on and so forth. We're almost done here. Now, here's what's interesting. In these articles that I wrote back in 2008, I said, here's what might work. Automatically collect a wide range of metrics over time. Build it into your development environment. And just collect all this data. And then after the fact, do analysis, machine learning or whatever, to find out which characteristics were most predictive of how the project was going, whether it was on later in time. And a lot of this came from one of my first projects post-college. I was at General Dynamics. I was assigned to work with an engineer. This is Cold War days, so this is Soviet Union, Eastern Europe. The Soviet Union's got all these tank divisions along the border of Eastern Europe, ready to invade into Western Europe. And of course the US has got spy planes and satellites to track them. Well, the Soviet Union started building these plywood tank shells that looked just like tanks from above and putting them on tops of trucks. So they had a giant shell game going. So they had lots of trucks and lots of tanks, and they would keep moving them around. And based on satellite pictures or U-2 spy planes, you couldn't tell which were tanks and which were trucks. So this engineer at General Dynamics had an idea to use side-looking radar. Get a helicopter that's standing like 20 miles off the border and is bouncing, pinging these vehicles, and is trying to tell whether or not they have tires or treads. And I was a programmer who did this work with him. And we did Bayesian analysis. We collected, he actually went out to Camp Pendleton and collected data with this radar on tanks and trucks. And then I wrote the program that went through and did the analysis of the characteristics and said which one gives us a sufficient separation. And we found with just 3 characteristics we could get 95% separation between tanked and treaded vehicles. So it was almost perfect identification, and it was very fast processing. So my thought was basically, someone should do this with software engineering. Well, I think it was a year ago, I had one of my students come up and say, yeah, I interviewed with a company that I think does this. It's called Git Prime, G-I-T Prime. And they do exactly this. They have a whole set of characteristics. They basically hook into your whole development environment, gather statistics, and they have done the analysis to figure out what are danger signals and what are good signs of progress. They were just bought up by someone else earlier this year. I forget who, but if you go to getprime.com and look at them, this is basically the first thing I've seen that tries to take this approach, and apparently they do it quite successfully. So, that's the end of it. let's take a biology break until 20 after. We will take roll, and then I'll go through the pertinent Gantt charts real quick.